Linux Out Loud is powering up the spirit box, contacting the ghosts of the old tech and haunted hardware. I'm Wendy, and tonight I'm joined by Bill and Nate as we brave the shadows of open source, poke around the dark corners of gaming, and maybe summon a few phantom processes along the way. Keep your sanity high and your flashlights charged. We're speaking of ghosts in the machines. This week, Linus Torvalds is drawing a line in the silicon sand. The debate over RISC-V Endianness has the Linux world split between freedom and fragmentation. We're digging into what it means, why it matters, and whether this Endian exorcism might haunt open source hardware for years to come. Welcome to episode 116, if you dare.
Ooh. Shouldn't we just retitle this episode 13 because that would make more sense?
It would make a little bit more sense, except for the fact that it is October and I was trying to figure out, okay, if I'm doing something fun for me, what is going to be the theme of the intro? And what I came up with was the fact that I do one of the few games I actually play is Phasmophobia. Not saying I'm good at it by any shape of the imagination, but it is one of the games that I play, and so it kind of pops into my head as the thing to do. My daughter got a kick out of it because she's usually the one that I'm playing the game with, so there you go. Now, Bill, normally it's Nate and I talking robotics, but this time you've had a little fun with the robots.
I sure did. Every once in a while, I have a spare Saturday on my hands, and I will reach out to my esteemed pseudo show and co-host and friend Neil and say, hey, what are you doing? And he'll respond with, well, there's a robotics competition near where I am. Why don't you come down here for the day? And we will see a bunch of robots fighting in different environments. Okay, cool. So this involves getting up at an unhealthy hour, driving a bit, having breakfast with Neil and a couple of other friends, and going to this particular robot competition, which is called the Norwalk Havoc Robot League. And let me tell you, it's like being front row seat to BattleBots. There's bots of all different shapes, sizes, build outs. And the three weight classes that we happen to see compete were 3 pound, 12 pound, and 30 pound. And let me tell you,
actual weight classes,
actual weight of the robots of 30 pounds, when they get together and they start poking and banging and cutting at each other, it's pretty loud and there's lots of sparks and lots of smoke. I actually saw a couple of robots catch fire when, for instance, there was one that kind of looked like a scorpion, except the end of the tail was more of a saw blade.
Ooh.
It pinned one robot in the corner and promptly cut it in half.
Wow.
Like just
see, our robot was like 32, 33-ish pounds last year, but it didn't have any weapons on it. Yeah.
These are built for destruction. And actually what's really neat about it is if you get the VIP pass, you can go upstairs to where the different teams are assembling and repairing and trying to put their robots back together, tuning them, programming them. And I've done this tour before, but a couple of my friends with young kids had not. And I said, you should go do the tour. It's really fun. So one of the teams actually let the kids hold the robot. They walked through like the whole safety checklist that they do prior to competition. And anytime that a robot is out on the platform of the cage, let's say, and it needs to be serviced, something is wrong, there are safety mechanisms that are put in place, almost like a rod in between whatever poking, breaking, cutting, pinning mechanism that you have, so they are safe to service. There's referees, there's lots of noise, shouting, cheering, food trucks, breweries, coffee shops, everything you can have in a possible scenario like that. It was just an insane amount of fun. I'm very glad I went, and I'm going to try to make a point to go more often.
How often does this take place?
This runs every quarter, and this particular quarter was the championships, and there were teams there from China, one from Great Britain. People fly in from all over the country for this because it is relatively close to New York City.
Okay.
So I'd say there's probably 6 cages there. So like the 3-pound robots have a smaller cage that's a little bit up higher, and those are actually kind of hard to follow because they move so fast. But the concepts that you apply in a smaller competition robot like that are almost different than the ones you find in the larger robots. I just had a blast. It was nice to be in the crowd and the scenery with all the hustle and bustle. And by the time 5 o'clock came around, I was ready to go home and call it a day.
Do they have like a Lego class also? Because it seems like that'd be a lot lower price point, because you can blast some Legos apart and then subsequently put them back together for the most part. As long as you're not cutting them. If you're concussing them, that would be, I'm just thinking.
I didn't see any Lego-based robots there. All the robots that I saw were obviously 3D printed, or they were welded metal or something of that sort. Okay. One of the robots there, that is the robot of the owner of the facility, has a flamethrower in front of it. So his stance is, I don't actually break or cut or poke robots. I just melt them. So that's kind of interesting. You're, just sitting there casually listening to banging and noises, and all of a sudden, whoosh, this huge fireball goes out in the robot cage, and that's kind of the end of the match.
Yeah, I can imagine.
So stay away from the business end of that one.
Right?
Stay away from the business end of that one. Absolutely. But just being able to look at the controllers and understand how the thought process of what you guys do with your robot competitions is similar and yet so different than that of these fighting robots. So that was a very interesting take, because obviously being around you guys and Wendy, especially you, with seeing your presentation in person versus what these guys are doing, I almost wish your team could come and meet some of these teams and exchange ideas and information and concepts. So that was just really a great overall way to spend a day. I can't rave about it enough. And I did put a link in our notes to the particular robot competition that I went to. So if you want to check it out yourself, by all means, go for it.
Wow. Even the little animation thing in the beginning there is pretty intense.
It is. And I've got the whole patch and the badge and the swag bag. And I went to buy a sweatshirt. They didn't have any in my size, of course. So that just means I have to go back and, get another sweatshirt. Or maybe I will 3D print a sweatshirt.
Ooh, that'll be super comfortable.
I think it can happen.
Something.
But maybe what I'll do is I'll ask Nate to print me this 3D sweatshirt, because he's been recently printing a whole bunch of stuff, which I kind of want to know more about. And could you take that concept and maybe make a sweatshirt for me?
I can confidently say no. But what I can say, because so you have to, the closest thing I could possibly print would be polypropylene, but I'd have to weave that, and that'd be really hard to do. I don't know if I have the equipment for that.
Yeah, and I guess you could make one out of TPU, but then it wouldn't be breathable at all. That would be really uncomfortable.
Unless you make it like a mesh sweatshirt, which could be very awkward for people.
Especially if you don't wear a shirt underneath it. Yeah.
Right. It's really hard to print thin with that as well. I noticed. So you have to. So some kind of like a chain mail. I could probably do like a chain mail. I think that would be likely. Not a sweatshirt, but a chain mail I could probably do.
Yeah, that could work.
You might be able to sell them at a Renaissance fair.
Probably could. Speaking of 3D printing, I don't always have the best results with it, and therefore this is my the project I talked to you about last time. I've been gone a lot for work, so I haven't had a lot of time to invest in this. But I have an in-between stage for my retro Enclosure machine. I think I did send pictures last. No, maybe I didn't send pictures. I don't know what I did. But anyway, so I have this is the card reader here. So I have a spot to put stuff. But I'll get it eventually here. One of these. What? Oh, here it is. Wrong one. There's so many slots on here. You got to get the right one. Anyway, but for most importantly, between the SD card, the micro SD, and the compact flash, these don't care about those. I don't have a somewhere. I have a Sony camera.
You have it in backwards, just so you know.
No, I don't. I had to look. Anyway,
made you look.
You did, and so I wanted to test the electronics piece of it. I only have basically a little bit of time here and there to work on this. So it's coming along very slowly. So this is going to be the color here, this Commodore 64 beige. This is just another beige I picked up that I wanted to prototype with, so I don't want to waste this beige. The fun thing is, this beige has been very hard to print. So I've had to make a lot of tweaks to get it to work, which is why I don't have a top for it. I have some examples of the top that look terrible. But anyway, and some of the design changes I made since we last talked was I made it so instead of screwing this in place, basically just kind of it's slotted in place.
Oh, that's
so
neat.
And then it's held together actually when the top goes in, but then it stays in. And so I got some a hub here to use that I'm going to go from like USB-C, which will pop right in the back, and then goes to this hub, and then I'll distribute the hub from there. Well, interestingly, when I plug this hub in, it has a very disconcerting smell to it. And also, it doesn't power anything up. So maybe I have a bad hub, or maybe it's just not a good design. Either way, I've opted for a different route than this, and I'm going to, because like wiring up the harnesses is going to be kind of time consuming and problematic because they're very tiny, and I don't have the the exact right crimpers for it. I'm still going to use some of the components from that, but I'm not going to use it exactly. So I got just a standard little USB-C hub. I will modify this and go right something similar, but I'll have it go the same kind of plug, but then go to a USB-C, another female USB-C, then have it go into the hub inside. And that'll just make it a lot simpler. I can wire that much easier. It's only 4 conductors since it's USB 2. And hopefully that'll work. But I do need to get the printer dialed in for this particular formulation of PLA so that it prints as I need. Because right now the vents are not printing properly on the with that PLA at all.
Fun fact with that card reader that you have, you mentioned that when you plugged it in, you got a nice smoky smell out of it.
No, not the card reader. This one, this hub here.
Oh, okay. All right. Because I've had a card reader like that. And when I plugged it into my board, it blew the card reader out, and I sent it back, got another one, did the same thing, sent it back, got another one, did the same thing, scrapped the brand. So I was going to say, if you're running into that, it may not be anything that you're doing with your wiring. It simply just may be a bad batch or not a very well-built solution inside.
What did I do? I can't find my other pieces. Anyway, it doesn't matter. I got some to go from the 2.54 millimeter pin style, which you can see so well in this lighting. Congratulations, Nathan. Cubicle Nate. I'll go right from this into the USB ports, like USB-A, and I'll plug those into the hub. So it'll be very simple. Not a whole lot of work there to do. Just basically making sure I don't get it backwards, and then and call it good. So I'm very excited about that. I'll have this. I'll at least electrically test it out to make sure everything works before I finalize this. I just got to print the top. I got the brass inserts so that instead of just screwing into plastic, I will actually put brass inserts into here so that I can stick it in there, so it'll be a little nicer. And then this will sit on my desk, not here, because out here I already have a card reader. I got an actual Commodore 1541 shell with a 5 1/4 inch card reader in there. So this is just going to be I use this on my desk in the house and I might make another one just for work, because sometimes I need a card reader at work, and then I have to like scrounge around for a thing, and then it's always really awkward to use. It's like a goofy little thing. Got to plug the thing to the side and then in. I just don't like it, but I think this will complement my 8-bit do keyboard setup so much better than anything else on the market.
It's the perfect accessory. It
is, and I'll have a little green LED light lit up here too. I'll do the whole. I'll go full nonsense with it.
Let me throw you another idea if you really want to go full on retro.
Mm-hmm.
When you're doing your pinout, get a serial port, wire the USB into different pins of the serial port, make it match, and then wire it back to USB in the inside. And that way you get the whole serial port vibe to it.
Which nobody would see, but I see where you're going with that. Ideally, I probably should have put it on the back, a serial port. Then I could have added a little bit more latency in the whole process and make it less usable. That's a great idea, Bill.
No, I'm not saying actually use serial port. Just use the DB9 connector.
Oh, I see what you're saying.
Yeah.
But to make it more authentic to the Commodore, I would have to use a DIN connector.
Yes.
That'd be more period correct.
Yeah.
But I'm also kind of lazy, so I'm designing this and working on that. I'm kind of lazy and I don't want to go that far. If I could just pick out a USB-C cable and then go with that, that's slightly easier. I even want USB-C, so it's a little bit more, It's actually easier to work with USB-C than the other standards. Slightly.
That's interesting. I learned something tonight. Cool.
Yeah. It's just simple. It's smaller. It's easy. They have all kinds of different form factors. You can pop it into something. And so I just got a little snap-in form factor. It's perfect. It fits in super easy, barely inconvenience.
Barely inconvenience?
Barely an inconvenience.
Awesome, I think.
Yeah. So speaking of inconveniences, you are also working on robots. And are these robots in disguise?
No. Unfortunately, we've got no Transformers around here. Just regular old Lego robots.
Funny glasses and a hat?
No, none of that. Not currently. Just chugging along in the season. I would say life has been pretty boring for me. Like I haven't had anything going on besides editing, being on shows. So you've probably seen me on DL a couple times here in the last little bit. Get better soon, Michael. But otherwise, like it's just been chugging along with robotics as far as that goes. The FLL kids, I think, are just working on attachments and then they can start coding, which is good because their qualifier is like a month away. So they really need to be getting on that and having that properly working and all that good stuff. And then the FTC team, they are well on their way to having the new design ready in theory. I'm going to say in theory because there's been a lot of that going on in the build room lately. Well, I think this will work, or this is what I would like to work, or all of that. And so we're still a lot on the prototyping stage. My son has designed some parts, tested them. They do work, not just in theory. And so I think tomorrow, because we're recording on a Tuesday, Wednesday, I have a special filament showing up that is for casting. So it's like doing a wax cast. The 3D filament burns out clean. And so that's showing up tomorrow. We can print the part and he can do his first casting of it to try and figure that out, make sure it's all right. So he has some couple tries, right, until it's on the robot. And I'm pretty excited for that. I think he's pretty excited for that. I think tomorrow I'm going to go pick up some 1/8 inch, because that's usually what they use for their side plates, is 1/8 inch aluminum. And we're going to go pick up some 1/8 inch wood sheets and cut them out with our laser cutter so they can test their side plates and stuff, make sure everything fits together the way they want, make sure the holes are placed right before we take that to the local shop and have them water jet CNC'd. Because I think the team has learned from definitely the last year that once something's cut, especially if you're pocketing it and you're taking like 95% of the material out of it, once it's gone, and you can't put it back in. And you may need to actually have a bolt go through there, and now you can't because it's all been pocketed. So I think we're learning from previous lessons.
Well, don't forget you're going to also need some 1/8 inch duct tape as well to hold the whole thing together.
Yeah, no kidding. Yeah, no kidding. So that's definitely been an interesting process at this point. So lots going on, but really not a whole lot going on. I'd say it's fairly boring at our house, just chugging along with the robotics program as it is. I should be able to use my printer here soon. The Coils,
right.
the FTC team, I know, right? Has their first scrimmage coming up the week before Thanksgiving, and so they're going to have an engineering portfolio ready for that. They should probably actually start working on it right now. Hint, hint, if any of you students are listening right now, go put in your information for the engineering portfolio so you're not doing it last minute, because we're not going to be there till 3 a.m. I don't know if that worked, but I tried.
In fact, maybe stop watching this podcast if you are and you haven't done it, and just go ahead and get it done.
Go work on your engineering portfolio.
Yes.
Yeah, most definitely. So yeah, pretty straightforward.
And if you need some help cheating with that, email me at cubiclenate.com. I can help you cheat. No, I'm just kidding. Don't do that.
He can help you. So, I mean, there's been some amazing engineering stuff going on with our students this year. They just have to properly document that and then make sure it gets into the portfolio. So go do it now.
I have a question, speaking of documentation, because in my line of work, that is very critical to IT functions. In your competition, is documentation something that is included in the scoring of your robot?
It's not included in the robot on the field, but it's definitely included in the judged portion of it. That's part of what your engineering portfolio is it's supposed to cover things like sustainability. So how are you not only raising funds to keep funding going, but how are you bringing in new people? It's supposed to cover your engineering process. What ideas did you come up with? Did they work? Why didn't they work? Why did they work? You know, your CAD files, all of that stuff. They only have 15 pages to put all of that in. And so that's where it can be difficult. Like, what information do you include and what information do you not include? The nice thing is they can have additional books and additional documentation in their pits, and pit interviews are a thing for FTC. So it's encouraged to put like the best, most important information inside of that 15-page engineering portfolio, and then have additional resources. So when judges come to talk to you, you can say, these are these other things that we've got going on. This is the stuff that we've used. So I'm hoping, that they've been doing awesome engineering wise, like just making sure they're getting that information put into the engineering portfolio this year is hopefully they're going to be doing, but we'll see. So yeah, life's been pretty boring. Spent a couple weekends in the mountains to unwind in between, but otherwise we're just chugging along.
Well, I think that's exciting. So you talked about the first LEGO League and then also FTC, right?
TC, yeah. So I've got FLL and FTC team. Yeah.
Okay. And how do you keep that straight? Like, how do you scheduling your life? How do you keep that straight?
So they both meet on the same days, and we just have the little kids meet before, and then there's usually like a half-hour break, and then the older team meet afterwards. Sometimes there's a little bit of crossover. So as we get close to, say, the younger kids are getting ready to have their state, their qualifier, whatever it is, then the older kids will come earlier, or the little kids will stay a little bit later so they can do their presentation for the other team. And the other team can say, hey, this is what went well. Think about this. Ask them questions from a different perspective. So the worst part right now is the younger team hasn't decided on an innovation project yet, which scares the crap out of me because, like I said, we're a month away from their qualifier. And so they need to have somewhat of a basic idea, and not all the way to what it needs at state, but they have to have something hashed out by then and something ready to go. So we'll see what happens. Our FTC is thrown in their hat to try to go to the Governor's Cup this year. They're doing that. This is the first time they're doing it for robotics. And so they've thrown in their hat in that. So hopefully we'll also be headed to Washington, D.C. in February.
So fun fact, the place where you went to for your robotics competition out here at WPI or Worcester Polytech, completely demolished the 3-pound league at NHRL. Like they absolutely crushed it. So you traveling around, and I remember you had done your stint at WPI, and now you're talking about going to more places. I wanted to throw that in there. So you see that not only are they doing the stuff that you're doing, they're also doing competition, combative league stuff as well.
Yeah, I'm not surprised that they kick butt. Like, I was so jealous of the robotics lab when we were there and got to do the campus tour. I was like, oh my gosh, I wish we could just hang out here all day and not leave. It would be amazing. But obviously, we just got to tour it. We didn't get to use it. I've got a topic for you guys, and I was going to bring this topic to Destination Linux, the last episode that I was on, but because it was the four of us, Ryan, Jill, me, and Nate, the show was almost 2 hours long in its raw form, not much shorter than that in its edited form.
Hour and 45 in the edited form.
Yeah, it was still like crazy long. So the topic that I brought to the show got pushed back, and I figured this would still be an awesome place to bring it up. I haven't ever used a RISC-V computer, but maybe some of you have, or the technology here that we're talking about. I know that Bill for sure will be using this with networking, but there's been a major debate that's erupted inside of the Linux world that, as some, I guess, could say, could shape the Linux future or open source future. So Linus Torvalds, in his signature, very blunt style, though I don't think there were any 4-letter words used when I was reading the letters back and forth. I think he had left those out at this point.
I think they were implied.
Yes, they were without a doubt implied, though they weren't said explicitly. Rejected the proposal to change the RISC-V processor architecture. The controversy centers around a technical concept called Endianness. And yes, I did look that up, and I found out that this terminology actually comes from Gulliver's Travels. So if you want to know more about that and how we get these terms, go check that out. But the implications are pretty big. And I would say that this is a classic battle between having the freedom of design and the practical needs for stability and a unified platform. I know it's one of the things that people complain about when they're looking at Linux or coming to the Linux is there's so many distros, there's so many different desktops. We're stressed, we're confused, we don't know what to go with, what is the best. So let's go ahead and break down this Endian war.
Does Endianness or Endian refer to people, things, objects that come from Endor?
No, this has to do with eggs and whether you're eating it from the big side or the little side in Gulliver's Travels.
Because I assumed that this was all about Ewoks getting involved somehow in the Linux kernel.
Nope. No, it has nothing to do with Ewoks. Nothing to do with them at all. So let's start off with, like, what the heck is Endianness? And the core part of this is I like to think of reading your numbers, right? So if you're going with big Endianness, that would be reading your numbers from right to left. Okay, the same way that we do, or left to right. Same way we do when we're reading our regular text, that kind of thing. Little Endianness is like reading your letters or reading the numbers from right to left. So depending on your culture, like one way is different than the other, but it's all how of that information, how those bytes are put into memory and where they're going to fit in those different memory addresses. I know that's a pretty big simplification on the whole topic. Bill or Nate might be able to give you a larger overview of that, but that's what really kind of helped me wrap my head around what's going on in here. And if we think about most computers, and most of you are doing this from an x86 processor, these are all using little Endian. It's become pretty standard in the PC world. Now, big Endian is something that's still pretty big in the internet. And one of the reasons why RISC-V was wanting to add big Endian into the Linux kernel was so that there was this layer that could talk to things inside of the kernel in the process of these different network protocols and the like. And, well, what did Linus say? No, absolutely not. And his reason for saying no is this is the standard already. And if you want to use Big Endian, there's already a layer inside of the different RISC-V protocols that allows you to do it. You can still do this inside. It does not need to be additional code that we're having to maintain inside of the Linux kernel. What do you guys think about this? What do you think it means for Linux as the future? What do you think of his putting his foot down in this discussion, this debate over Little Endian versus Big Endian?
Well, so I understand his point of view, and that so everything is structured, has been structured the same way, and they have extensions for operating outside of the main way, and so I think to keep things, you either have to keep it that way, or I feel like you're going to have to fork the kernel heavily to be able to switch it the other way, or you're going to introduce a lot of other unnecessary complications to how the kernel operates. So, because there could be, if you're switching the direction you're reading the bytes in the kernel as like that, as it could go either way at any point in time, I think you're going to potentially introduce a lot of new vulnerabilities or aspects that might be compromised. So to me, it looks like having not changing that and leaving it as an extension seems like the smarter way to go. And as far as what comes like RISC and Big Endian, Little Endian, I actually have a PowerPC machine that I had. I believe it was Little Endian because I had to get that specific kernel for it to work.
Mm-hmm.
And it didn't quite work right. But anyway, it did work, but
But yeah.
So I know it's compiled differently for that capability. So it's not like that. I guess I'm not really sure. So even after reading the article, I'm a little confused as to why it's even a controversy, because it's not really I mean, I understand it's not in mainline kernel support, but I understand where his point is that it's risky and expensive for a company to develop in that way. So I think sticking to Little Endian, although I realize network switches like Big Endian is it's the standard, so sticking with that would make sense in that regard. But it does seem kind of dicey. I mean, there's I feel like that with hardware, there's been so many rapid hardware changes recently that who knows? I mean, maybe Big Endian is the way forward for more power efficiency and more capability, but now just may not be the time for that, which is why I think he didn't completely close the door on it. So
well, and we know for sure that sometimes the best technology doesn't always win. That's become the standard for computing as far as that goes. And maybe if there wasn't an existing extension, it's called ZBB, which can do that byte swapping.
Right.
And supposedly, pretty fast. I've never had to deal with it myself. But that's part of the reason why it's like, why add additional complexity to the kernel? Because I know here in recent years, they've actually been dropping some of the older technologies, and I'm not like 2-3 years old, but for the much older technologies out of the mainline kernel. And potentially why bring something back in that could then bloat your kernel again, possibly add some other layers of bugs, some other layers of maybe access points for bad actors. I don't know. But what are your thoughts on this, Bill?
The first thing that came to mind was encryption and encryption algorithms. Like, how does this affect that? And the short answer is they're still read linearly, so that doesn't really matter. But if they have to sort of cross somewhere in between, that's where things can get dicey.
Yeah.
I also look at this as the best way to put it being is how much change does this introduce into the Linux kernel versus other projects. So, for instance, if you add, great example, the driver that I needed for your laptops that I shipped you, when Neil and I were configuring those, we found that there was a bug in the kernel. We submitted a patch upstream, and lo and behold, it was approved and introduced and merged. That's a very minor change to the Linux kernel. Adding a file system is a bigger change to the Linux kernel. There's been debate about ButterFS and Bcachefs, and that's kind of a bigger change. And I think what Linus is getting at here is we're now getting to the lowest layers of the Linux kernel, the actual way that ones and zeros are processed. And he's saying between the power of hardware being what it is now, and the fact that I already have an out for this, what you're asking us to do makes for unnecessary work. So I kind of, when I work, I adopt this 90-10 rule, which is, am I going to sacrifice 90% of my effort for only 10% more reward? Or am I going to focus 10% of my work to get 90% of my result? So I think what he's saying here is the 90-10 rule applies. You're going to make us apply 90% of our engineering resource to get a 10% benefit. I don't see a lot of RISC hardware out on the market right now. It's still really, really new, and it's prohibitively expensive. The network gear that I use every day, none of it is running RISC-V. It's just not mainstream enough. Even in a NAS box, I don't see it. I still see a combination of low power x86 chips like Intel N150s, N100s, Celerons, even some i-series chips, or even the like low power Ryzens, or I see it on the ARM side. So those are the two things there. Now, ARM is its own cautionary tale because there's technically not really a standard ARM. There's Raspberry ARM, there's Annapurna Labs, there's Qualcomm, there's a million different iterations of ARM. And one of the things that Linus is saying, in my not so professional opinion, is we already have a fragmentation issue. And now you want us to make that exponentially worse without a meaningful justification for the effort.
Yes.
But he did leave the door open.
Yeah, exactly. He leaves that open with something along the lines like, hey, if it becomes relevant, like if it gains significant market traction on its own, then of course the mainline kernel should support that. Then that it's something that it's definitely worth us putting our time into. But as of right now, it's such a small portion of users of hardware, of stuff out there, that right now you already have a layer, an extension that can handle that stuff. So it's all right. So I know this argument might rub some people a little the wrong way, right? Because it's one of the things that we've heard as Linux users as, why don't we have access to this software on Linux? And it's because, well, there's just not enough of you. So we're not making that software for Linux, right? So I can understand where some of that's like, ouch, you know, we'd grow more if there were some out there. But I think we can kind of lighten that just a little bit, because there is a way to make it work. There is a way to run those things, and it doesn't have to be at this point reliant in the kernel to have that functionality of swapping how those bytes are read, both left to right or right to left.
And because there's that mechanism in place to handle that, I think just from my own reading earlier today, what you may run into is, let's say you bypass that and you just start to do this straight up. You could, in theory, break how, for instance, AES 256 encryption algorithms are read. And while that may not, it may cause vulnerabilities, it may not, but it would certainly be an annoyance for anybody trying to authenticate things like SSH keys.
Yeah, obviously it could add more heartaches. It could, in the process of trying to make one thing easier, make a whole lot of other things harder or more vulnerable. So it's that give and take, that 90-10, as you were saying before, like, where is the best places to put our efforts?
Or you could also apply that where I fixed 10% of the bugs, but I introduced 90% more somehow. Programmer's conundrum.
Oh, yes. We've seen that before, both in programming and hardware. More so of like, okay, we've got to move this thing that was really, really bad last year on the ARM that they had. We're going to move this thing to make this better, and then not being able to get other things to work, and me leaving the build room at 1 a.m. with an hour drive home. Yeah. Sometimes it's better to just leave it the way it is, or prototype something out, right? To take this idea, make a branch, play with it to see how things work. And then once you have it in a state that won't destroy things for some people, then it's okay to possibly bring that to light for it to be usable.
So I guess where my thing is, even after reading everything and then the arguments on both sides for big versus little endian. So again, I guess big endian is also called network order. Little endian is not. So I don't see where there's a processing advantage in how you store the bytes in memory. That's I guess that's the part that I'm confused about, is like, how is there any advantages one way or the other? I can understand in network traffic because you're sending it as you're speaking it. I guess that makes sense. But in storing it in memory, what does it matter on how it's stored? Maybe I'm just ignorant. I haven't read enough yet, but it does seem like a little bit of we're getting really down in the weeds on this one. But the thing is, like, to the performance, any high performance processors fetch multi-byte operands from memory in the same amount of time they could have fetched a single byte. So the complexity of the hardware is not affected by byte ordering anyway. So I guess that's why, guys, to me, like, for any sort of high-powered device, this really doesn't have a whole lot of
right.
I don't understand that. But for smaller devices, lower power devices, I can see where there may be some advantages.
I'll be honest with you, all of the network equipment that I see out in the field is running some sort of ARM variant, or even in some cases x86. I have not yet run across anything that's running RISC-V at all in the field. But granted,
so in
I'm
most
also
cases,
not,
a lot of them would be using little Endian anyway.
Probably, but granted, I'm also not taking my network equipment apart, disassembling it just to see what's going on under the chassis. I'm just trying to plug it in, configure it, get it out the door,
get the
move on
client
to the next
ready to
thing.
go and stuff. Yeah.
But what's kind of interesting to me is something that happened today, which was the acquisition of Arduino by Qualcomm. And the reason why I think that matters here is because Arduino is a huge player in the Linux space. It's the Tinkerer's board. SB32 projects are based off of it, which are very useful in Home Assistant. There's a lot of things that kind of happen there. Maybe that golden investor comes along for the RISC-V scene, swoops up all that IP, all that intellectual property, and then provides the resources back to the Linux community that says, hey, we're going to sponsor this. Hey, Linus, if Acme Anvil Company, who has just purchased this particular product, is willing to invest time, resources, and developers into this, would you be more amenable to introducing this back into the mainline kernel?
So my question is, do you think RISC-V would actually sell and become closed source? Because right now it is open source hardware as far as CPUs go. Or are you thinking more along the lines that one of these major players picks up RISC-V as being a chip in one of their major projects, one of their major systems?
I'll flip the script on you here then. Imagine if Intel x86 code had been open sourced from the beginning. Do you think we would have as much cohesion in the Linux kernel as we have now? I actually don't think Linux would be able to exist.
Maybe not.
Because there's no single point from which to build on at that point. If it's just this fragmented architecture that everybody can implement however they want, to me, now you're taking a software problem of fragmentation and throwing that problem at hardware. Now you have no foundation from which to build upon.
So what you're saying is there is a sweet spot to the amount of structure and closedness to an architecture in order to be able to flourish as a platform.
Absolutely.
I'm not necessarily closeness in general, but having a set, I don't want to say protocol, but a set way of doing things, that this is what that architecture looks like. And we can do all kinds of cool things from here, but we all have to start from the same base, the same map, in order to make sure that all these other cool projects can be cohesive across multiple platforms.
This is the same thing that we had with, and Nate, you'll be able to relate to some of this, PowerPC, M68K, MIPS, the DEC Alpha chips that were out way back when. There were certain constraints that developers had when they were creating Linux distributions that would work on those chips at the time. It said, here's your instruction set. A processor has an instruction set. Mm-hmm. This is kind of set in stone. It is hard written to the silicon inside the chip in order to make it work. If that was completely open source, imagine trying to design software around every single person's iteration of hardware out there. You would have this weird chicken and egg scenario of, well, is your hardware designed to run the software? Well, I have to ask you, does your software run on my hardware? Well, I don't know. Does it run on your software? I don't think you would be able to do that. And I think I like the idea of RISC-V being conceptually open source, but I think in order for people to rally around it, they're going to have some sort of base from which to build upon.
Yeah. It's kind of one of those things, like there's no way we'd have the programs that we have now on Linux if there hadn't been a solid base to build from.
Yeah. And maybe this is actually why when you said like not always the best technology is adopted, that maybe what is best is not necessarily the highest and best point of any particular feature of it, but a net average of features that allow for the most productivity to flourish. So for instance, Betamax, which was technically better in some areas, didn't have all of it wasn't just by cost, because by cost it was really roughly the same, but because it didn't have the length of the lower quality, you could have longer runtimes in VHS. So it was adopted at larger mass because of one aspect of it was superior than the rest, than like the quality necessarily. So although that's an old technology argument that nobody cares about anymore. So I think that it's interesting, like what about the technology allowed it to flourish from its base point? You know, the 8088 or 8086, whatever, it went from being really not the best processor, actually less efficient than like the MOS technology 6502, because although both 8-bit processors early on, the 6502 could get more work done in the same number of cycles, essentially. But it was the 8088 that went beyond it and was iterated upon, while the 6502 essentially kind of sort of died or faded away, not entirely, but in favor of other technologies. So it's interesting to see like what caused one to do better. Was it just the marketing, or was there something else, some other factor that made it, develop upon? ARM has been around for a long time. The Acorn Archimedes, that's anyway, that processor has been around for a long time, and only in recent years really has it taken off. So what is it about ARM? I know it's more power efficient, but what is it now that it's making it a contender against the x86 platform where it did not, 20, 30 years ago? I find all this stuff very interesting. I don't fully know it, but I do find it quite fascinating, because
interesting rabbit holes to run down for sure.
Yeah, it is an ADHD rabbit, especially.
What's like on this show, chasing an ADHD rabbit, as I referenced on the last DL.
Which is why I brought that up, because it made me laugh twice.
Bill, you have a really awesome tip for everyone this week, which it actually got brought up pre-show as we were having kind of our pre-show conversation. Hey, what had everybody been up to? Yes, we have some kind of like, I guess you would say, warm up and cool down before and after the show. And so this tip got up, and I think it's an awesome one that everybody needs to know.
Invest wisely. A fool and his money are soon parted.
Okay, that's not where I thought you were
that's
going.
My problem.
But
all right, I wanted to make you laugh. We don't have to throw that in there. I'll do it the right way. So yes, I do have a pro tip for those of you that interact with multiple Linux systems. I'm going to assume and be confident that you are interfacing with those systems over SSH. And in doing so, that you are using SSH keys in order to use passwordless authentication to your systems, which is a very secure way to access one Linux system from another. But what happens if you lock the keys in the car or you misplace them? Well, you have a big problem on your hands. So SSH keys come in two parts: a private key, which you never give out to anybody, only you know that, and a public key, which you can basically put out on the world for things to authenticate against you. I happen to be a fan of storing my SSH keys in either my Bitwarden instance here at home or in a Bitwarden account. Yes, Bitwarden, the personal version, the $10 a year one, does support SSH key pairs, and it actually saved my bacon at work the other day, where somebody had assumed that an SSH key had been saved. A system failed. We needed to get back into it. We needed to reflash things, get an SSH key that was known to work, and hey, who's got that key? And crickets. Well, come to find out, it was in our Bitwarden instance that we self-host. We were able to pull it out, reissue the keys. Everything was fine. That still doesn't mean you shouldn't rotate your keys from time to time. You should rotate your keys at a regular interval. That is just good practice. But when you do rotate those keys, make sure you are saving both the private and public key in a place that only you can get to. So again, multi-factor authentication is something you have and something you know. So you can protect those with YubiKeys. You can protect those with other FIDO or other compliant systems that will ensure that your data stays safe, because you never want that private key to get into the wrong hands. So that is my pro tip, is make sure that your SSH keys are backed up somewhere safe and secure. You rotate them and you verify that you can actually access your private key and see that it's there, and that the internet ghouls and goblins that tend to crop up around Halloween haven't somehow gobbled up your key.
And I've actually used Bitwarden's Authenticator app, and I really like it. So if you're already using that system, it's a great one to add to your list of security protocols.
So in there, you can add, obviously, vault items such as a website you log into. You can add in a private note. You can add an identity. And yes, there is an option in there to add an SSH key.
That's pretty cool.
Give it a try. Let me know how it goes for you guys the next time I'm on your show. I'd be curious to see how it worked out for you. So speaking of needing to recover systems with different things, Nate, I understand that you had yourself a little mishap this week with one of your machines.
Well, it actually wasn't this week. It was last week. I did some updates on my Commodore 64 Imposter, my C64X, whatever you want to call it. The thing that looks like a Commodore 64, but isn't really. It's actually an ITX-based machine, which is a video on cubicalnate.com if you want to. Well, yeah, the video on my Cubicle YouTube. But anyway, not for nothing. So the problem was not Tumbleweed. Tumbleweed did not fail me. It was this. This failed me. It's my NVMe. It decided that it would stop doing the work of an NVMe, and I do actually know why I mean, it was already problematic ahead of time. I saw the warning signs. The smart control told me, and I didn't listen, and then it died. But not a big deal. I had another NVMe, so I just had to restore my machine. And that takes really about 18 hours to do. You're probably like, why so long? So, well, the all my data that I have on my computer on the main drive, I should say, is all mirrored with my other primary computers that I use that I can take anywhere. So I could at any point in time, if I had to utilize this computer to do most things as my framework, by most I mean like 99%, and I might have to add some other configurations to get it to do the rest. Or I have another couple laptops that I can hop in. So if I were to smash my framework, I've got a backup, and I don't lose any data in that as well. So this was so corrupted that I tried to use like the Btrfs repair, check and repair, and it basically told me I should go pound sand. Not like that, but it said it was so corrupted that there was no fix for it. And then I tried to format this to see if I could, just use it just because I like to play with technology, and it wouldn't format. So I did some other terminally things to see if I could try and get it to format. I got it to format, but I don't know that I trust any data going on this if I have to work super hard just to get it to be recognized as a usable place to put data. So I decided not to. And also if I plug it in, the smart control thing just kind of complain a little bit at me as well.
Something to note, I was actually getting smart errors on one of my NVMe's in my server rack, and it was because it was getting too hot.
Mm-hmm. So and that's actually was the cause of it. So in this build, I added a fan because it was getting too hot. So I have it sucking and blowing at the same time. And
get a passive heat sink on your NVMe as well.
Well, actually, I have an active sink on my NVMe now.
Great. So you've solved that problem. But that's the number one reason I see NVMe drives like that fail, is because oftentimes the build is too small. There's not enough airflow, or simply there's just not a really good heat sink, or none at all. And you lose valuable hours of potential life on that.
Well, there was none at all. This thing actually had already failed once, and I just moved it to a different location. So I mean, I did numerous things wrong. So it's all about like, let's see if I can.
Like playing with fire, yeah.
Yeah. It was all about, let's see how far I can push this thing, and it lasted basically almost another year.
Okay.
That's pretty good.
No, that's not true. Wait. I think I just lied. No, it was about a year. Actually, it's about a year.
I would say you misremembered, not lied, if that was going to be the case. But
right, I misremembered. It was last summer that it happened, and yes, it was about a year. About a year, yeah.
Oh, nice. So a little over a year then.
Yeah, ish. So I squeezed another year out of an already failing NVMe, and actually, it's amazing. So if you want to watch like the logs, like Btrfs does a really good job of going through and correcting things and shifting stuff around. And eventually I think it just got to I think the drive was too full. I got to its limits, and then it couldn't compensate for it anymore.
One of the things that I've always appreciated about the OpenSUSE distribution is that really cool snapper tool that's built into it for you to be able to take snapshots of your system very quickly, efficiently, send them off somewhere, send them back, and recover a system from it.
Yeah.
Yeah, but I didn't want to do that. There's some fun in just like starting from scratch again, like on the configuration settings. So, that was fun.
I do like having a squeaky clean system sometimes, right? Everything is fresh. There's no cruft. There's, it's just nice and clean.
This particular machine that I'm on is the same Fedora installation that I have been running since Fedora 32.
Wow.
Nice.
That's got to be what? That's 6 years?
Because we're at 40.
Yeah.
42 or 43?
We're at 40
right now.
We're at 42.
Okay.
43 is in beta. So I'm still on that. And yes, it is showing signs of cruft and issues and little problems here and there. But the idea of having to spend the time and reinstall and bring everything back, I do that for a day job. That's the last thing I want to do when I get home.
Well, and I get it. And it's not something that I do for a day job, but it's more like do I have time to get everything back up and running before I have to have this system for work, for editing, for those kind of things? And so it's one of those things that I'm only undertaking when I know I've definitely got some wiggle room. Well, it's part of the reason why when I went back to Fedora and was still having some issues, I was like, well, after these things, then I will be back on Manjaro, but it's not something that I can do right now because I just don't have the time. So actually, I had done my desktop first, and then I went back to Manjaro on my laptop later, and then didn't really use it for the summer to edit there just because we didn't have as much going on robotics-wise. I was able to get most of that done at home before we had to be there. So I was doing an edit of one of the shows. I think it was DL, most likely DL. That's the one I'm typically trying to get wrapped up there at the build room. And I was like, holy crap, what happened? Where are all of my whip template stuff? Yeah, I'd never reinstalled it yet because I hadn't actually needed it yet. Thankfully, all of that is on my SD that goes with me everywhere, which I probably need a second one of those because if that SD card dies right now, I'm kind of in trouble. I'm in a lot of trouble. That's where all of the show data is. I've got to get that multiple places.
So today's second pro tip from me is back up your data in at least 2 places. I've said it on the show before, and I'll say it again.
Multiple times. Yes. I've got to. I got to get it somewhere else and fast. Because it's not the shows themselves. Because once a show's edited, I rarely need to access it again, and usually I don't need to access it. It's just because there's a joke back and forth, and I'm like, oh, that would be really funny if I could pull this thing back up. But what would be painful to lose is some of those things that I use like every single show, some of those little assets like the intro animations and that kind of stuff. So yeah, I will get those backed up like right after we're done.
Just as an aside, I don't want to belabor this whole thing, but I do take snapshots, like backups of my incremental backups of my main computer, and I did actually lose a piece of data because I was stupid. It's not important what it was. Let's just call it an SSH key. But so I went to back up to pull my backups of that, and that drive went kerchunk, and didn't come back. So that key is lost forever. It's not like a huge loss. It's just a super inconvenience. Because I don't do completely passwordless on a lot of things. I still have passwords on a lot of stuff. So I could just push my key back over. Not a big deal, but highly inconvenient. So, there's that.
There is that.
Yep. Now I've actually got a new backup strategy I've decided to implement, and I'm also going to do the cheapest I could find for like glacial backup. That's not going to destroy the bank for the 7+ terabytes of data is with a company I don't want to promote. So anyway, I'll just leave it there.
I have a couple of different options for you that may be more cost effective, and hint, they will work with your NAS.
Yay!
Well, I'm at about $8 a month is my target number. So I don't know if you can beat that.
Well, both of you have a Synology NAS device.
Yep.
Mm-hmm.
And Synology NAS devices can back up to each other.
Mm-hmm.
Just throwing that out there.
Oh, no, I'm doing that already. But I want to have like let's say this entire area gets flooded, either with radiation from the nuclear plant or water. Either way, and both buildings are leveled or destroyed with water, I'd like to be able to get my data back. That's the only reason I have it. It's just like
Offsite. Strictly offsite.
Totally, completely offsite. Yeah.
Well, not for nothing, but in a hypothetical world, you could have a Tailscale instance in another part of the country where maybe one of the other podcasters on the show lives, and systematically back up to that part of the country seamlessly. Just throwing
That's
it
a
out
possibility.
there. Yes.
It could be an interesting way to work that.
Probably have to set up like a
Yes.
relay for that, I'm thinking.
No relay needed.
No.
On another show or offline, I will give you
just a subnet router?
Just a simple schematic of how to do it.
How that works.
I would think if I set up just another subnet router, that'd probably work.
You're overcomplicating
So I could jump from mine.
it.
Am I? Okay.
So the joke is 3 engineers are on a show and they're trying to figure out how to back up an SSH key. There's the punchline.
Oh, Bitwarden.
But if any of our interests, if any of our audience is interested in exploring backups again and different options, I'm always happy to, with enough notice, to draft something up and share it with the community. Maybe revisit some of the best practices that are out there, strategies, easy ways to do it, examples that are already available in Git or wherever else.
Nice. Yeah, that might be a good thing to add to the repertoire.
I think another thing too is it doesn't have to be a perfect solution. It just has to work.
Well, that's all for this hunt, investigators. You can, if you captured any EVPs or just want to share your favorite ghost stories from around the world of tech, drop them on the discourse forum under this video or through the contact form at tuxdigital.com/contact. Stay in touch with us on our social media and check out other shows haunting the halls of tuxdigital.com like Pseudo Show, Destination Linux, and Linux Saloon. Before you leave the safe room, grab some blessed swag from the Tux Digital merch store, maybe even some #Team Wendy shirt to keep the ghosts at bay. As always, we thank you for tuning into Linux Out Loud. We'll be back with another awesome sode soon. Until then, keep the banter friendly, the conversation somewhat on topic, and remember, don't say the ghost name unless it's root.
Ghost BSD?
Ghost BSD.